Hello, and welcome back to Calero Academy. Today, we will be investigating the second way to find the limit, as theta goes to 0, of these two areas. The shaded area over the dotted area. So we want to find the limit, as theta goes to 0, of the shaded area A over the dotted area B. So, in the previous part, we found A in a very easy manner, and found B in a tricky manner by finding the area of a kite and subtracting away this sector. So we can mark this as R, P, and Q, and of course the origin. So OPQ is a sector of a circle, and PR and QR are tangents to the circle. So, how do we find B? A is going to be the same. So A will be equal to theta r squared on 2 minus r squared on 2 times sine theta. So that's going to remain the same. And in the previous part, we actually wrote r squared over 2 sine theta as r squared over 2, as r squared sine theta on 2 cos theta on 2. So here we're just going to write it like this. So A stays the same. There's no really innovative way to find A that's going to be much different than the first approach, so stick with this. Now B, the way we're going to find B is instead of subtracting the sector from the kite, we are going to subtract A from the triangle to get the dotted area. So B is equal to the area of triangle PRQ minus A. So what is PRQ? PRQ, so it's actually quite easy. You just split this into two triangles. Recognize that since this is 90 degrees, you recognize that this is 90 degrees, as we talked about in the first part, and then realize that the angle QPR must be theta on 2. And that's because the angles in a quadrilateral are 360, and we have theta here, and we have these two angles being equal. And actually, forget I said that. So the easier way to recognize that this angle PQR, angle QPR is equal to theta on 2. And the way we realize that is by realizing that when you chop this angle in half, you have theta on 2 over here, and you have 90 over here, and by some algebra, and look, so this triangle over here has 180 degrees, therefore theta plus 90 plus this mystery angle alpha is equal to 180. Therefore, that mystery angle is equal to 90 minus alpha. 90 minus theta is equal to the mystery angle over 2. And therefore, since OPR is 90 degrees, therefore QPR must be theta on 2. I won't do too much stuff like working out that tedious stuff. So anyway, moving on. What we have now, when we know that this is theta on 2, we have a theta in our triangle. And therefore, we can just do some trigonometry and that was similar to what we did before. And we can get our area very easily, and we'll find that B is equal to the area of that triangle, which turns out to be r squared times sine squared theta on 2 times tan of theta on 2 minus A, which is equal to theta r squared on 2 plus r squared on 2 sine theta, because of the minus sign. Okay, so we have this. Now, what do we do now? So it turns out, that we are going to have to use L'Hopital's. And it turns out you need to use L'Hopital's a lot. So let's rewrite our limit. Our limit as theta goes to 0 of a over b is equal to the limit as theta goes to 0 of theta. And when we write this, let's just cross out all the r squareds. As we can see, r squared is in every single term, so we can just divide throughout by r squared. So on the top, we have theta on 2 minus sine of theta on 2. All divided by sine squared theta on 2 times tan of theta on 2 minus theta on 2 plus sine theta on 2. So, now I'll outline what you must do next. What you have to do next is very similar to what you did in the previous video, part A. So you're going to actually have to do L'Hopital's a little bit more. So you had less algebra to do, but it was a bargain with the devil. You had to do much more of L'Hopital's. So you're going to have to do L'Hopital's 4 times. And what you're going to have to do is, whenever you see secant squared, 1 over cos squared, you have to substitute 1 plus tan squared, like before. And so after you do L'Hopital's 4 times, and at the end you'll have a denominator with a dozen or more terms, a little bit of a nightmare. But after that, it will all pay off. Because in the end, you will have your answer as 1 over 1/2, which, as we saw in the last video, is equal to 2, which is the right answer. And in part A, I promised you that we would also outline 2 other methods for solving this problem which are not rigorous. So, the first way is to use a graphing calculator. So, here's a graphing calculator. This is the graph of our function, and as you can see, it's quite a weird function. So, and as you can see, it goes up to 2, it approaches 2 on both sides, although it's undefined at x is equal to 0. And with the help of a graphing calculator, you can see that. Now, the second method is to just plug in values of theta into our limit over here, and see that it starts to get very, very close to 2. Starting from below, going up, reaching past 1, up there, like that. And so that this ends part B of our video. We hope you enjoyed it. If you have any comments, please put it into the comment section. And if you want us to make a video of anything, also do the same. So thank you again for watching this video, and goodbye.